All right, so again, we've got the hockey player. So we're really interested in the puck. The puck travels in that direction. It's not square. Amazing. I can draw circles. Ovals. What is the magnitude of the force of friction? All right. In this case, the force of friction is the coefficient times the normal, right? How else could we define force of friction, though? The puck is slowing down, right? So it is accelerating in the negative direction, decelerating. So we could also say that the force of friction is equal to the mass times acceleration. Because friction is causing, it is a force, it is causing the acceleration, we can also define it this way. We can't use this part because we don't know what the coefficient is. We're actually asked to find that in the second part. So we have to use MA. So we say that force of friction then is mass times acceleration. Do I know the mass of the puck? Yes, what is it? $114 grams? Can't use that because we have to have kilograms. Its mass is 0.114. We have to use kilograms. Now, do we know what the acceleration of the puck is? No, I could find it though, right? Because I do know that the initial velocity is 6.7. What's its final velocity? 0. Distance is 18 meters. And we want to know acceleration. Do I have an equation that involves those four things? The answer, of course, is yes. The true question is, what equation do we have that relates those four things? Vf squared equals Vi squared plus 2AD. V final is 0. Vi would then be 6.7 squared equals 2A 18. Now algebraically, I got rid of a negative sign there because I know that the acceleration is going to be negative because it's slowing down. So just to make it easier, I just ignored the negative sign when I brought the Vi squared over the other side. So 6.7 squared divided by 2 divided by 18. What is the acceleration then? Hopefully you're catching on that I don't have a calculator. Neither have I actually done the problems. I've done them, but I don't have the answer at my disposal. Yes? If it causes an acceleration, you can use F equals ma. Because the puck's slowing down. Yep. Friction will never cause something to speed up. That would be silly. It would be crazy. So what is my acceleration? Okay, I'm going to suggest you guys close the computers. You know, like I say, losing the vote, that's nothing compared to losing the game. Concentrate on the game. Oh, so you'd rather everyone in the state of Minnesota knew you got your butts kicked. Concentrate on the game. All right. So what is the acceleration? 1.2? How many significant digits do we have? 2. Okay, because the 18, the 6.7, we've got 2 significant digits to deal with. 1.2 is our good answer. So our frictional force is 1.2 meters per second squared. Mass, So what is the frictional force between the puck and the ice? 0.14? Now, does that seem like a small frictional force? Yeah. It's a hockey puck and ice. There's not much friction there. That's the whole point of hockey, is it glides. So what's the coefficient of friction? Well, the coefficient of friction is only found in this equation right here. So our force of friction is 0.14. Our coefficient is what we're looking for. What is the normal force in this case? The weight of the puck. The weight of the puck is its mass. Get rid of the puck here. 0.114 times 9.8 meters per second squared. Because weight is mass times the acceleration of gravity, which if you're on Earth is 9.8. So the coefficient then would be 0.14 divided by 0.114 divided by 9.8. Coefficient. Now, before you even punch the numbers through, are you going to get a big number or a small number? Should be a very small number. Small coefficients mean slippery surfaces, not very much friction. Bigger numbers, stickier, more friction. So what do you come up with for the coefficient? 0.13? Anybody else? Good? So 0.13. Normal force is no. No, it's a mu. Now, we'll get to that. Not always. Now, what are the units on it? On coefficient of friction? Doesn't have one. Why doesn't it have one? Because it's force divided by force. Newtons divided by newtons, they cancel out. Coefficient does not have one. Most coefficients don't have units. All right. Questions on this one then? So again, frictional force, if it causes an acceleration, is mass times acceleration. It's always the coefficient times the normal.